Yeah, it has a lot to get done. Okay. All right, guys, here we go. Related rates. This is Unit 4, Topic 4.4 and 4.5. Put it in your calendars. We will probably have an exam next week on Thursday. Well, next week. It's more than a week. We're good. We're good. Rihanna sponsored this one. You got to show your work, work, work. You guys ready? Yeah, see? You get it. She gets it. Okay. So here we go. This is related to implicit differentiation. All right, come on, Miss Bruno. Let's close our laptops, guys. Let's close our laptop. Let's focus on this, please, because it can be very, very tough. Assuming that so let's just get right into it. Finding related rate equations. Assuming that the radius r of a sphere is differential function of t and that v be the volume of the sphere. Find an equation that relates dv dt and dr dt. Well, first and foremost, you got to know the equation of a sphere. So volume of a sphere is 4/3 pi r cubed. Bless you squared. Do we at least know that? Okay, right. They'll probably give you, if this were an AP exam or some type of assessment, they'll probably give you the major formulas. I'm not sure if they'll give you the sphere one. I want to say yes, but I can't guarantee it. All right, so what does it say here? Find an equation that relates dv dt and dr dt. So they want to see both of those variables, the dv dt and dr dt. So that means I'm taking a derivative with respect to what letter? T. So I'm going to write dv dt equals the 4/3 pi is a constant. So I'm just going to multiply by 3. What's 4/3 times 3? 4 pi r squared. But I didn't take the derivative of r with respect to r. I took the derivative of r with respect to. So I write dr dt, just like when we were doing implicit, but just with t in this time. And there it is. That's my equation that relates dv dt to dr dt. And we're done. Yeah, I did 4/3 pi times 3, and the 3 cancels out. I did power rule, yes, with respect to t. Do we have any issues here, guys? All right, letter B. Assume that radius and height of a cone are differential functions of t and let v be the volume of a cone. Find an equation that relates dv dt, dr dt, and dh dt. All right, so here's a cone. Let me draw a cone for you guys. Here's R, here's H. Volume of a cone is equal to pi over 3, or 1/3 pi, R squared H. They would probably give you that one, but I would just memorize the ones, the ones that come out all the time. A rectangular prism, a cone, a sphere. Are we still okay? Okay, here we go. When I take a derivative, what rule do I got to use? Well, yeah, it's chain with the dr dt dv. But product, if the pi over 3 is giving you a hard time, then just do this, guys. Pi over 3 is a constant, right? So here we go. dv dt is equal to, and maybe this is more ideal, leave the pi over 3 alone, that's just a constant. Product rule first times derivative of the second plus second derivative of the first. Is anyone confused? You're confused? Tell me, where did I leave you? You could have grouped the pi over 3 with the r squared if you wanted to. I decided to just leave it alone because that's just a constant. And I did product rule. First, derivative of the second. What's the derivative of h with respect to t? dh dt. Plus second, h times derivative of the first, derivative of r squared. 2r dr dt. It's just a constant. Remember, okay. In case the pi over 3 is throwing you off, look, here it is. I'm just going back, side note. Y equals 10x squared. That 10's a constant, right? You could have done this. Y prime equals 10. Leave the, what's the derivative of x squared? And look, you still get your same, see? I would have gone, if I would have gone 10 times 2, 20x. You could always leave the constant alone and then just take the derivative of whatever you're looking for. Yeah, what just like it has to be a constant, power over 3. You know, you could have grouped the power over 3 with the r squared, and then I would have had a power over 3 in here, and then I would have had a 2 power over 3 right here. You could have done that, you know, but I didn't do that in my mind. Cool? Okay. How are we feeling, guys? Anything crazy so far? Okay. Here we go. Our first example. And it deals, maybe I should have done example 1, example 2, like after the letter A, because it's a sphere. A spherical snowball is melting in such a manner that its radius is changing at a constant rate, decreasing from 21 centimeters to 10 centimeters in 30 minutes. So let's see, 21 centimeters to 10 centimeters. What's that? Negative 11 centimeters over 30 minutes. At what rate is the volume of the snowball changing at the instant the radius is 3 centimeters? Okay. Before I do anything, and let me slow down. Maybe I should have been more specific. This right here that I found, let me rewrite it. Negative 11 over 30 centimeters per minute. This is a dr dt. Because this is the rate at which my radius is decreasing. Does that make sense, guys? All right. So here we go. I'm going to write my formula for volume of a sphere. Volume equals 4/3 pi r cubed. And what they want, at what rate is the volume of the snowball changing? They want dv dt, question mark. Y'all ready? All right, here we go. dv dt equals, multiply the 4/3 times 3, 4 pi r squared dr dt. dv dt equals, I'm going to plug in, 4 times pi times 3 squared times negative 11 over 30. All the units check out. Everything's in centimeters. So centimeters squared times another centimeter, you're going to get cubic centimeters per minute. Are we still okay? Let's see. 3 squared is 9. 9 times 4 is 36. 36 pi times negative 11 over 30. I'm going to take my calculator, and I'm going to go 36 times 11 over 30. So here's my calculator. Yeah, we're going to need calculators, guys. Do you guys want to grab some calculators if you don't have any? That's a beautiful picture. There it is. I'm going to put a pi on it and a negative. You okay? Cubic centimeters per minute. You don't say centimeters cubed. I guess you can, but it's cubic centimeters. Yep, that's it. How do we feel, guys? Okay. A highway chase. So direction matters. This is actually one of my favorite related rates questions. This one and the balloon. These are realistic questions, I think. Okay, here we go. I'm going to go slow. We're okay. Miss Kyla, you're all right. No, yes. Here we go. A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, The police determined with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? What makes these hard, guys, is the attention to detail. So creating a model. So they told me I'm at a right-angled intersection. So here's my right-angled intersection. I'm going to put not to scale. Not to scale. North is this way. East is that way. So here's my police cruiser. Here's the good guy. Well, assuming. And here is the bad guy. Are we still okay? If you count north as positive, so then this cruiser guy is going, when the cruiser is 0.6, okay. So do not, okay, time out. Try not to put numbers on your grid or your scale because then you're creating something that is static. It's not moving. This is moving in real time. So put the letter X and the letter Y. When the cruiser is 0.6 miles north of the intersection, so that's Y equals 0.6. And the car is 0.8 meters to the east of the intersection, so X is 0.8. So this is like my origin, 0, 0. Are we still okay? Okay. Let's see. The police determined with radar that the distance between them and the car is increasing at 20 miles per hour. That is this. So I'm going to call that Z. dz dt is going 20 miles per hour. Is everyone okay so far? I haven't done anything crazy, right? I don't even know how fast the car is. The cop's going. Where does it? If the cruiser is moving at 60 miles per hour, there it is. The cruiser is dy dt. That's the speed. Now he's moving down on the y-axis. So instead of calling it 60 miles per hour, I'm going to call it what? Negative 60 miles per hour because it's going down on the y-axis. Are we okay? And then if the cruiser is moving at 60 miles per hour, then it's in a measurement. What is the speed of the car? Okay, so I am looking for dx dt, question mark. Are we still okay, guys? All right. I know what z is before you even start. I know what z is with Pythagorean theorem. X squared plus y squared equals z squared. So 0.6 squared plus 0.8 squared equals z squared. 0.36 plus 0.64. Because I need the z, guys. I need the z. Z equals the square root of 0.36 plus 0.64. 64 and 36 is 100. So 0.64 and 0.36 must be 1. You could have taken a calculator if you wanted to. Or just know that these are special triangles, 0.668. Okay, I'll stop. We're still okay, guys? Okay. Here we go. The relationship that ties x, y, and z together is, Pythagorean theorem. So I'm going to take a derivative of x squared plus y squared equals z squared, but I'm taking the derivative with respect to what letter? T. What's the derivative of x squared? 2x, but is it a t? So what do I put next to it? Perfect. What's the derivative of y squared?
2y dy dt.
What's the derivative of z squared?
2z.
Perfect. You are done with calculus. The rest is algebra. I think, it is just my opinion. You guys tell me. What's up? I'm taking the derivative with respect to t.
So why does it change to dy over dt?
Because I take the derivative with respect to t. It's not, is y a t? No. Is x a t? Is z a t?
No, I'm just confused why you're changing the variables.
I'm not. I'm taking the derivative with respect to t. It's like chain rule. X squared, and I'm taking the derivative with respect to t. D dt. So the derivative of x squared with respect to t is 2. Leave the inside alone. And then what's the derivative of the inside with respect to t? Dx dt. 2x dx dt. Do you see it or no? No, you can say no. I didn't hear what you said. What is what? Well, first and foremost, what the question was, I want to know what dxdt is. So in order for me to get a dxdt, I need to take this expression, x squared plus y equals z squared. That's what relates x, y, and z together. That's why it's called related rates. And I'm taking the derivative with respect to the letter t. So the derivative of x squared with respect to t is 2x dxdt. The derivative of y squared with respect to t is the same thing, but with a y. Y is dy dt. And the derivative of c squared will be the same thing, but with a z. d2z dt. Does that make sense? So remember, why are we doing what we're doing? Okay, because that was the initial question. Why are we doing what we're doing, Miss Kyle? Because I am looking for dxdt, and the relationship that binds x, y, and z together is Pythagorean theorem, and that is what I'm going to take a derivative of. Okay, don't worry, we're fine. We're fine. Okay, are we okay so far, guys? All right, let's factor out a 2 on the left-hand side. Yep. Because I thought that would be easier, unless you wanted me to leave it, but. Okay.
No.
And then I could just divide both sides by 2 or just cancel out the 2's. Does that make sense? All right, so here we go. Here's what I now have. X dx dt plus y dy dt equals z dz dt. Once you divided both sides by 2, right? Divide by 2, bam, bam. And I'm just doing algebra. I haven't done any calculus. The only calculus was the first line. Is that okay?
Yeah.
All right. You can, and in physics, they isolate the dx dt. You can do that. Sometimes I do it, sometimes I don't. When do I decide to do it? When do I decide to don't? I think when I have an expression like this, it's just easier to just plug in numbers for me. If for you, you want to isolate the dx dt and then plug in, that's fine. I like to plug in right here, everything. So what was my x? So I'm going to go 0.8, and then dx dt is what we're looking for, dx dt, plus what was my y? And then I know my dy dt. What's my dy dt? Negative 60 equals z, which is 1. From the word problem right here. But it's moving down, right? The z was 1, guys. Remember? The z was 1. That's your z. What was your dz dt? 20. Are we okay? Okay. Here we go. 0.8 dx dt. Make sure that point doesn't float like mine just did. 0.8 minus, I want to say that's 36, because 6 times 6 is 36. And I have 60 times 0.6. So minus 36 equals 20. Are we still okay? All right, I'm going to move what? Up 36. So 0.8 dx dt equals 36 plus 20, 46, 56. 56. And now I'm going to take that. What am I going to do? What's my next move? Divide by 0.8. Number literacy. I actually don't know off the top of my head what 56 divided by 0.8 is. 70? I thought he would have been going faster than that, but that's fine. Oh, yeah. 8 times 7, 56. Duh. Okay. All right. There it is. How fast is the bad guy going at that exact moment? 70 miles per hour. So you can see you're doing the same math that NASA does. We're rookies, so we have to start with the easy ones. And then we'll go to, well, when you become a math major, you'll do 2 variables and 3 variables, you know. Huh? Well, some of you are math majors. Some of you are doing actuary, so you'll do 2 and 3 variables. You will eventually.
It's a lot of work, but I feel like it really isn't.
Yeah. Let's go to the next question, guys. Yeah, it's cool, right? Okay, so the hard part is creating a model. That's the hard part. So let's see what this says. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from liftoff point. Oh, okay. Pretend you work for NASA. Here's your job interview. See if you can do this question. No, this is realistic. At the moment the rangefinder's elevation angle is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? Okay, you get this question as an interview question for trying to work at NASA. Can you do it? No, say yes. Heck yeah, you can. All right, so here's your interview question. Let's draw a model, guys. You okay, Rodriguez? So let's draw a model. Here you go. Here's my model. There's my flat land. Here's the hot air balloon. I'm just going to draw a circle. And let's see, perpendicular to the ground. And here's the rangefinder. I'm just going to put a little dot. And And what is static? Let's see, 100 balloon straight up in level field is tracked by a rangefinder 500 feet from liftoff point. 500. So this is perfectly fine to write. It's 500 feet from liftoff point. That point right here is lift. Lift off point. What? Say it again. I could have written it to the left. Yeah. I just like to do everything to the right because I'm right-handed, and I'm gonna say that my grid starts here, so that's 0. Way over here is 500. You know what I mean? But you could have done it to the left. Doesn't matter. Are we still okay, guys? All right. So what letter do you want to use? We could use Y, but do you guys want to use a different letter than Y for the height of this balloon? No, that's not a letter, miss. Yeah, don't do that again. Y? Okay. Y. There's Y. No, that's fine. It doesn't matter. H, or whatever letter you guys want. Okay. So there's the Y value, and this is the angle. I know the angle is pi over 4, but write theta, because remember, if you write pi over 4, you're making it static. You're making it stuck at pi over 4. Are we still okay? Yeah. So let's see. The angle is, so what do I know? The angle is increasing at a rate of 0.14 radians per minute. So that is your d theta dt. 0.14 rad per minute. All right, what else? And okay, that's it. What do they want? What do they want? How fast is the balloon rising? What's the symbol for that? This is Y. Is it Y? Yeah, they want to know how fast is the balloon rising. What do they want? They want dy dt. Write that down. Dy dt. Put question mark. This is what we want. Like the notebook. What do you want? Dy dt. Oh yeah, the notebook. It goes. Oh. Okay. All right, let's focus. You're gonna make me cry, guys. All right, no, we're good. All right, we want dy dt. Question mark. Are we okay so far? Everyone's good. All right. So here we go. What relationship? Think about it, guys. What relationship uses 500, theta, and y? No, you're not going to say Pythagorean theorem this time. SOHCAHTOA. See? Well, okay. Let's talk about it real quick. Let's say it again. The y, the theta, and the 500. So here's what you say. You guys all took pre-cal and geometry. With respect to the theta, is that y opposite, adjacent, or hypotenuse? Opposite. What about that 500? Which one am I going to use? Tan. Yeah, TOA. So here it is. Tan theta equals y over 500. That's the hard part, guys. That's the hard part, creating a model. Are we okay? All right, next, in this case, I'm going to go ahead and isolate the y because, see, sometimes I don't, sometimes I do. I'm going to multiply both sides by 500 times 500 times 500. And here's what I get. I'm going to write the y first, guys. So I'm going to write y equals 500 tan theta. Get up to here. Are we still okay? All right. What do we want? So what do I got to do to this expression to get dy dt? Find the derivative with respect to what letter? T. So here we go. Dy dt equals 500 is a constant. Leave it alone. What's the derivative of tan? Secant squared. You got to keep the argument. So 500 secant squared of theta. Is that theta a t? So what do I put on the side? No, not dy. D theta dt, because I took the derivative of theta. Chain rule, right? Okay. Are we still okay? Do I have d theta dt? Do I have theta?
Yeah.
Yes. They gave it to you. They gave it to you right there. What is my theta? Okay, so here comes pre-calc, not even extreme pre-calc, just baby pre-calc. Here we go. 500 secant squared of pi over 4. We'll figure that out in a little bit. D theta dt was 0.14, 0.14. Are we still okay? All right, here comes our baby pre-calc. Here's pi over 4. I guess they're being nice, right? Because at pi over 4, they're both the same. So here we go. 500, giant parenthesis. Secant the reciprocal cosine. Even if you would have messed up on this one, you still would have gotten it right. 2 over square root of 2. Close it. Put a square on it. Times 0.14. So let's see. 500 times 2 squared is 4. Square root of 2 times square root of 2 is 2. 4 divided by 2 is 2. And 2 squared is 4. I want to say that's 4. Check my word just in case.
Do you think they'll give us enough time to do this?
Yes, they will. They always give us enough time. I haven't multiplied yet. Let's see. 500 times 4. Oh, it should be 2? Yeah, I make mistakes all the time.
Found the test.
2 squared.
And you failed.
4 over 2 squared. Guys, it's 4. 4 divided by 2 is 2, and then you squared and it's 4.
You squared. You're like doing it twice now. You squared that again. Because the square of 2 over 2 is the 4.
Oh, yes. Yes. Yes, yes, yes. What am I doing? No, I'm still half asleep. This weekend was a killer, and I have my mom still over. She made me get up early on a Sunday to get barbacoa for her, because barbacoa at the Calubra market. Yeah, and she's like, no, they're gonna run out. So we went. I was there at 6:30 in the morning, and guess what? Okay, 500 times 2 is 1,000. 1,000 times 0.14. Let me see. Can I do this correctly? 140. 140, and I need units. Let's see, feet per minute. Does that make sense? A hot air balloon going 140 feet in 1 minute. Yeah, it makes sense. Now, if it would have been 140 feet in a second, guys, that's pretty fast. Make sure that the units make sense. Because sometimes you guys give me. Last year, I was laughing so hard. Do you guys remember the rotary motion quick test that we had last year? Someone told me that some person was biking at like 45 million miles per hour, and I just couldn't stop laughing. Like, guys, think about your answers. Like, I mean, I remember writing on that paper. It might have been one of you guys. Is this person Superman? 'Cause 54 million miles an hour. Come on, guys, on a bike. Shh. They should at least try to make sense. 20 miles an hour, 50 miles an hour, a reasonable speed, you know? Not 54 million miles an hour on a bike. Okay. Feeling a conical tank. So we're close to the end. This one has 2 ways to do it. Of course, we have to show the hard way, guys. If for some reason it doesn't make sense to you, just slow down and we'll do it again. Water runs into a conical tank at a rate of 9 cubic feet per minute. This is a very common question. Have you guys ever worked on a farm before?
Yes.
No? Yeah. So conical tank. There's conical tanks all the time in farms, right? Right, here we go. Water runs. So here's water. Here's the water. Water runs into a conical tank at a rate of 9 cubic feet per minute. So that's dVdt. 9 cubic feet per minute. That's dVdt. dVdt. No, that's water in a conical tank. A tank in the shape of a cone. We're in Texas.
He said.
No, I mean, I wasn't trying to be sassy. Was I sassy? I wasn't trying to. Sorry, miss. Yeah, no. It's just a tank in the shape of a cone. That's all. The tank stands point down and has a height of 10 feet. Of course, if there's water in it, it has to be point down so you can. All right, here we go. This, you can write 10 feet on it because that's how big that tank is. and has a radius of 5 feet. So the radius of this big tank, that's a big conical tank, 5 feet. Yeah. How fast is the water level rising when the water is 6 feet deep? Okay, so this pivot here is closed. So we're just throwing water in here at a rate of 9 cubic feet per minute, and we want to know how fast it's rising. Obviously, because the walls are getting bigger like this, it's rising at a decreasing rate, but it's still going up. We're not there yet at that level. You know, how fast are we rising at an increasing or rising at a decreasing? Next one's on the merit, miss. All right. Let the record show Esquivel yawned. All right, here we go. Volume of a conical tank, pi over 3 r squared h. Probably. Probably. For this one, for a cone. Which one would they not give you? A rectangular prism would not give you. And I think a sphere, they might give you that one. Maybe. Okay. Are we still okay, guys? All right, here we go. I'm going to do it just like we did last time. I'm going to take the derivative with respect to what letter? T. dv dt equals, leave the power over 3 alone. First, r squared times root of the second, dh dt, plus second h times root of the first, 2r dr dt. And I think we're good. Well, yeah, I'm going to write what we do have. Did I mess up? First times root of the second, plus second, 2r. Yeah, we're going to get it, though. Yeah, I have dvdt, but they're not asking for that. Maybe they're asking for how fast is the water level rising.
But you're solving for dvdt.
No, I'm not solving for dvdt. Okay, guys, I just took a derivative. We have dvdt. They're asking for how fast is this water rising. So because this is h, they are asking for what?
I understand it. Because you have to change the h.
Yeah, they're asking for dh dt
So you have to take the derivative of the original formula.
to get my dh dt in there. So, Rodriguez, help me. Okay. Guys, the relationship between the volume and the radius and the height, this is just a relationship. I don't have to, yes, I know it says dvdt here, but guys, remember, we're just gonna plug in dvdt and solve for dht. This is just an expression how dvdt, dht, and drdt are all related. This is it. This is your calculus. Everything else is going to be algebra. So what do I want? I don't want dvdt. I already have that. I want dht. Does that make sense? Okay. We're going to use geometry.
No.
Tell me, Miss Kyle. V-Man.
I had Kyle for geometry. I'm telling you.
No, you learn this. Look, I'm telling you right now. Do you see this big triangle in blue? Oh, let's not use blue. Let's use black. Do you see this big triangle in black? And do you see this triangle in orange? They are similar. They're not exact, but they're similar triangles. Do you guys remember that? So here it is. I'm going to come to the side here, and I'm going to write my similar triangle. I'm going to go, let's see, where am I going to go? 10 is to 5 as h is to r. Do you guys see what I did? Oh, you're good. You're good.
Get away from me. I don't want to be next.
Are we still okay? Okay, what happened to Leon?
No, we're good. Josh is being a little.
All right, hey, focus, guys.
We're good.
Okay. Anderson, we're pretty good on this. I'm sorry, miss. I just want to make sure that we're good. You're good? Okay, here we go. Let's cross multiply. Here we go. 10, or I guess you could, well, I already said cross multiply. 10r equals 5h. Are we still okay? All right. Which one do you want to get by itself, the r or the h?
The R.
All right, well, let's see. What do we have? Do we have the radius? Yeah. The radius, no, we don't actually have the radius. We have the radius of up here. How fast is the water level rising when the water is 6 feet deep? What do we have? We have h. So that means I don't want to see an r and I don't want to see a dr dt. So don't worry, we'll fix the r in a little bit. Or actually, we can get the r in a little bit. So here it is. I'm gonna get h by itself. Divide by 5. Divide by 5. So h equals 10 divided by 5 is 2. I guess it didn't matter. You guys ready?
And H is a height.
Yeah. dH dt, I'm taking the derivative of that, equals 2 dr dt. Yes, yes. That's the height of the little triangle in orange. We're still okay?
Yep.
Yeah, maybe I should have gotten the dr dt by itself. It doesn't matter. It's really simple. So we're good. All right, we're going to play the substitution game in a little bit. Or we can just plug in. All right, from this, let's figure out what r is. R equals h over 2. R equals 6 divided by 2, which is 3. Are we still okay? All right. So let's zoom out and see what we have. We have R, check mark. Do we have DHDT? No, that's what we're looking for.
How did you know R is equal to H over 2?
From here, from the similar triangles. We have H, check mark. We have R, check mark. And we have DRDT, not directly, but we have it. Not directly, but we have it. Are we okay? All right, here we go, guys. I'm going to plug in. So dVdt. What's my dVdt? 9 equals pi over 3, parenthesis. My r. What's my r? 3. So 3 squared is 9. Write dHdt on it. Plus h, which is, what's h? I don't know. 6. 6 times 2 times 3. Are we still okay? And then drdt. Here's what we're going to do for that one, guys. Yeah, we should have stopped for drdt. No big deal. To get drdt by itself, we just divide by 2, right? So we can say that drdt, I'm going to write it right here. Yeah, drdt is equal to 1/2 dHdt. Okay, that's what it means to divide by 2, right? 1/2. Uh-oh. Okay, make sure we know that, guys. Dividing by 2 means the same thing as multiplying by half. Okay, that's what I'm plugging in. So that's it. So I'm going to go times 1/2 dHdt. Don't worry, we'll verify that we have the right answer in a little bit.
Is that a 2 times 3 or is that a 2.3?
That's a 2 times 3. That 2 is this 2. And the r is 3, remember? We're okay? Okay. Are we still okay, guys? All right, bless you. 9 equals pi over 3, bracket 9 dHdt, plus, let's see, 2 times 3 is 6, 6 times 6 is 36, and what is half of 36? 18 dHdt. Combined like terms. We're done with calculus. We're done with calculus with the first 9. We're just adding. 9 equals pi over 3, bracket 18 plus 9, 27 dHdt, close it. Are we still okay? Okay. 3 goes into 27 how many times? So 9 equals 9 pi dHdt. And how do I get dHdt by itself? Divide. dHdt equals 9 over 9 pi, which equals 1 over pi. And I need units. Feet per minute. All right, there it is. We'll find out right now if we made a mistake, because we better get the same answer. Are we okay so far? Okay. Is there an easier way to do this? You saw this was hard. If you don't pay attention to detail, guys, it's very easy to not be able to do this. Yes, this is going to be on the AP exam, guys, so we gotta be battle tested. All right. Can we do that example easier? Well, the fact that I wrote that in here, probably the answer to that is what? Yes. Relax, we got it. You don't have to rewrite it. You already have it. Okay. Relax. Look, it's going to be a lot easier. So volume equals pi over 3 r squared h. What do we want? I guess first let's write what we have. We have dv dt, which is 9 cubic feet per minute. We have h, which is 6 feet. We have, what do we want? We want dh dt. Okay. You could have done this. You see how you just, and by the way, they tricked, when we do a free response question, you're going to see they trick someone so bad one year. This doesn't always work. This doesn't always work because the relationship is not always in there. You'll see later on what I'm talking about. You see how they just want dh dt? We could have replaced that r with h with doing similar triangles over here. Remember this, so this is r, this is, let me go ahead and write, this is r and this is h. And remember we did similar triangles earlier. We got this relationship right here. So we could have done that. We could have said, let's see, 10 is to 5 as h is to r. I hope I did that up there. Yep. That's the same relationship. Remember that, guys? And then we could have done this. You could have done 10r equals 5h. And remember, I want to replace the r. So I could have divided by 10, divide by 10. Look, there's my 1/2 h there. R equals 1/2 h. And I could have done this. I could have taken that r equals 1/2 h, and I could have plugged it in right here. So I'm going to write volume equals pi over 3, parenthesis. Instead of r, I'm going to plug in 1/2 h, close it squared, times h. And now let's see what this expression is with algebra. Volume equals pi over 3, parenthesis, 1/2 times 1/2. 1/4 h squared times h. What's h squared times h? H cubed. Volume equals, what's 3 times 4? 12. So pi over 12 h cubed. Yes. Do you know what the volume is? We don't know what the volume is. We just know the dv dt. You know what I mean? We don't know the volume of the tank. We just know like how much we're at. We just know the dv dt. So we have two unknowns. So we can't solve it. Okay. Are we still okay, guys? Ask. Okay. Ask, guys. Okay. Here we go. Remember all I wanted was dh dt? Look what happens. dv dt equals 3 pi over 12. We'll reduce it right now, guys. H squared dh dt. I know, and we don't know, but that's what we want. Power rule. How many times does 3 go into 12? 4. Plug in. 9 equals pi over 4. H was what? 6, so 6 squared dh dt. All right, let's see. 6 squared is 36, so 9 equals 36 pi over 4 dh dt. Oh, look at that. 36 over 4 is, so 9 equals 9 pi dh dt. And then just divide by 9 pi. So dh dt equals 9 over 9 pi, which is 1 over pi. And I need units. Feet per. Did we get the same answer? Which one do you think was easier, guys? What do you guys think? Say it again. Oh, because sometimes densities of, in this case, it's going to always work. But there was a free response question where the rates were not related. These rates are related. That's why they're called quote unquote related rates. Yeah. Eventually. All right. So don't worry. I think I already I've been putting everything on Canvas, miss. I don't know if you saw that this morning. We will start off with simple delta math to get you guys like used to this. Followed by a handout tomorrow. So there's not going to be a lesson tomorrow. Just practice. And a UH quiz called rates. Attempt by 10:22. So we got plenty of time. And due by 10:29. Guys, time out. Notice how much time I give you for this one. There's a reason for that. This one tends to be pretty tough for you guys. So please take it early so you can ask me questions because it tends to be pretty hard. Because the hard part is creating a model. Does that make sense? Cool or not cool? What's up? I think it's quiz 9. Okay, then it's 10. Quiz 10. Implicit's due by Friday. By Friday, next week. Or this week, Friday. All right, guys, that's it. Log into Delta, please. Make some practice. And we'll call it a day.